Hello everyone, and welcome back to the channel. I'm Juarez, keeping the automation running for Mexico. Today, we are building a classic industrial automation project, a fully functional traffic light sequence. We will program the latest logic inside TIA portal using a Siemens S7-1200 PLC, and then we will visualize and control the entire process through a custom SCADA dashboard in LabVIEW. First, the TIA hardware configuration. Let's start right here in Portal in your device configuration. I'm using the CPU mm, 1214C. We need to verify two crucial settings for LabVIEW connection to work later. First, on the protection and security, we must check the box that permit access with. In this case is here, double in PLC, and protection and security in this, and down. Check this permit access with put and get communication. Second, under system and clock memory, we need available clock memory byte. I assigned this to byte 1. We will use this system clock pulses to make our green light blink automatically without writing extra complex code. In this case is this here and down. E is check. Now, do you remember the save the project? Moving over our main block, let's look to the sequence. In segment 1, we have standard. In this case, it's in semaphore. Segment 1, we have a standard startup launch circuit using internal memory bytes activate the main system flag. And from segment 2 down, we use a cascade of tone timer of control the traffic. Light passes. We begin with a 5 seconds timer for the solid green light. Once the finish is triggered at 2 seconds. Timer for the blinking green fast. This is followed immediately by a 3 seconds timer for a yellow light, and finally 5 seconds timer for the red light with reset the cycle. Down in the final segment, we link the timer output to our actual physical output for the light. The achieve the blinking green effect, we simply add a condition using 2 Hz clock pull from memory bytes enable here is here. The another segment is here. It's the sequence to light green, and segment 4 is the sequence to light yellow, 3 seconds, and then another segment 5 is the sequence to let red. If the time is 5 seconds. In the sixth segment is the change in the system on. E segment 7, yellow, light yellow. E segment 8 is lead red. Okay. Another thing is the NetToPLC configuration. Now to bridge our TIA portal simulation to the outside world, we use NetToPLC. When you click Start Server, you might see a warning popping up saying that port 102 is in use. Don't worry about this, just click Yes, stop. On the running, pay close attention. Your network address in my case is a 192.168.0.100. We must use the specific IP address. When setting up our PC server, not the default PC address. In my case, this is configuration. Okay, to for explain, the before is stop server modify. This is the name of the PLC. This is the network IP address. Is a router. In my case, is simulation. Is Siemens PLC virtual Ethernet adapter. Okay. And this is the EP for PLC. Okay, a slot is 1, this rack is 0, and okay, and start server. Now, L9 OPC server. If you know run OPC server is here. Click right and configuration. Next, we map our tags in L9 OPC server using the Siemens TCP AP Ethernet driver. Let's do quick checks using the UPC quick client. As you can see a screen of Boolean variables, the start button, stop button, and the tree like are successfully liked and updating the real time. For example, to AD tags is here, new tags. For example, stop send. The address, for example, is M 0.2. Check this. The type is Boolean. Description is here. Apply and okay. Apply is a tag with a specific name array exists. Okay, acceptar 1, for example. Apply. If you know add another tag, only this icon for new. In my case, no is necessary. Okay, this is a new variable for UPS. It's not necessary to use practice and delete in this moment. The list and same one? Yes. If you know check the communication with a NetToPLC, OPC server and TIA portal, only quick a client. In this case is this. You check in one semaphore PLC and all the variables, the quality is good, 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 good for all. Okay. And now the communication LabVIEW and front panel and block diagram. Finally, let's break is all the live in LabVIEW. For example, here minimize. Mm, okay, stop. In my case, if do you know add the variable is in this case is here in my computer, a new and EOS server, OPC server, OPC client, sorry, continue. Wait a few seconds, please. And you select this option, National Instrument, NEOPC servers version 5. And okay, can you see this is a new library and split the tree. Add a new create the bound variables in this split the tree and this library and EOPC semáforo PLC1 and add all the variables here, here in add and okay. In this moment, the variable is variable to working with the. In my case, no is necessary and delete this library. Remove from project. Save. Only the tag library, okay. In this moment, I need to refresh in this deploy all. It is ready. Save the project. And here in front panel, here, design a clean intuitive HMI with a custom traffic, like graphic and standard start and stop buttons. If we switch over the block diagram, you will see the wiring is very straightforward. We drop or shares variable with a bound to our OPC server inside a standard web lab. The start and stop buttons are configured to write the data to PLC, while our volume indicator simply read the output signals. To animate the light is also added a 5 milliseconds wait timer to keep CPU order. In this case, it's 5, or you change to 100 and save all. And that brings just the end of this project. Is to build a complete automated traffic light control system, going all the way from a raw layer logical to a functional SCADA dashboard. In this case, it's only a test. Here, run. Um, this practice is running. Stop. Start. If you have any question about the logic the NetToPLCsim configuration or the LabVIEW waiting, please leave a comment down below and we'll be happy to help you out. If you found value on this video, please don't forget to hit the like button and subscribe to the channel. It really helped me create more industrial automation tutorials like this one. As always, I'm Juarez, keep the automation running for Mexico. Thank you.